Right. So today I'm going to learn Langchain. I'm going to learn Langchain finally after such a long time. I want to learn Langchain. But then I keep on like postpone. And then today I finally say that you know what, I can't like wait any longer. It's time for me to learn Langchain and see like what's the hype about. All right.
Welcome to this short course on Langchain for large language model application development. By prompting an LLM or large language model, it is now possible to develop AI applications much faster than ever before. But an application can require prompting an LLM multiple times and parsing its output, and so there's a lot of glue code that needs to be written. Langchain, created by Harrison Chase, makes this development process much easier. I'm thrilled to have Harrison here, who had built this short course in collaboration with DeepLearning.ai to teach how to use this amazing tool.
Thanks for having me. I'm really excited to be here. Langchain started as an open source framework for building LLM applications. It came about when I was talking to a bunch of folks in the field who were building more complex applications and saw some common abstractions in terms of how they were being developed. And we've been really thrilled at the community adoption of Langchain so far. And so look forward to sharing it with everyone here and look forward to seeing what people build with it.
And in fact, as a sign of Langchain's momentum, not only does it have numerous users, but there are also many hundreds of contributors to the open source. And this has been instrumental for its rapid rate of development. This team really ships code and features at an amazing pace. So hopefully, after this short course, you'll be able to quickly put together some really cool applications using Langchain. And who knows, maybe you even decide to contribute back to the open source Langchain effort.
Langchain is an open source development framework for building LLM applications. We have two different packages, a Python one and a JavaScript one. They're focused on composition and modularity. So they have a lot of individual components that can be used in conjunction with each other or by themselves. And so that's one of the key value adds. And then the other key value add is a bunch of different use cases. So chains of ways of combining these modular components into more end-to-end applications and making it very easy to get started with those use cases. In this class, we'll cover the common components of Langchain. So we'll talk about models. We'll talk about prompts, which are how you get models to do useful and interesting things. We'll talk about indices, which are ways of ingesting data.
So there are a few components here. So let's see. Components. So one is the model, the prompts, and then we have indexes.
So that you can combine it with models. And then we'll talk about chains, which are more end-to-end use cases, along with agents, which are a very exciting type of end-to-end use case, which uses the model as a reasoning engine.
We're also grateful.
Sorry, what's the chains?
Chains, which are more end-to-end use cases, along with agents, which are
chains, agents. Okay.
Are a very exciting type of end-to-end use case, which uses the model as a reasoning engine.
We're also grateful to Ankush Golar, who is the co-founder of Langchain alongside Harrison Chase, for also putting a lot of thought into these materials and helping with the creation of this short course. And on the DeepLearning.ai side, Jeff Lodwick, Eddie Shu, and Diala as a team have also contributed to these materials. And so with that, let's go on to the next video.
In lesson 1, we'll be covering models, prompts, and parsers. So models refers to the language models underpinning a lot of it. Prompts refers to the style of creating inputs to pass into the models. And then parsers is on the opposite end. It involves taking the output of these models and parsing.
Okay, so parsers are basically, parsers take the output and parse it into the format you want.
Parsing it into a more structured format so that you can do things downstream with it.
Yep. So when you build an application using
so that you can do downstream tasks with it. Okay.
LLM, there'll often be reusable models. We repeatedly prompt a model, parses outputs, and so Langchain gives an easy set of abstractions to do this type of operation. So with that, let's jump in and take a look at models, prompts, and parsers. So to get started, here's a little bit of starter code. I'm going to import OS, import OpenAI, and load my OpenAI secret key. The OpenAI libraries are already installed in my Jupyter Notebook environment. If you're running this locally and you don't have OpenAI installed yet, you might need to run that. Pip install OpenAI, but I'm not going to do that here. And then here's a helper function. This is actually very similar to the helper function that you might have seen in the ChatGPT prompt engineering for developers course that I offered together with OpenAI's ease of forward. And so with this helper function, you can say get completion on what is 1 + 1, and this will call ChatGPT, or technically the model GPT 3.5 Turbo, to give you an answer back like this. Now, to motivate the Langchain abstractions for model prompts and parsers, let's say you get an email from a customer in a language other than English. In order to make sure this is accessible, the other language I'm going to use is the English pirate language. When it comes to this R, I'd be fuming that my blender lid flew off and splattered my kitchen walls with smoothie. And to make matters worse, the warranty don't cover the cost of cleaning up my kitchen. I need your help right now, matey. And so what we will do is ask this LM to translate the text to American English in a calm and respectful tone. So I'm going to set style to American English in a calm and respectful tone. And so in order to actually accomplish this, if you've seen a little bit of prompting before, I'm going to specify the prompt using an F string with the instructions to translate the text that is delimited by triple backticks into style that is style, and then plug in these two styles. And so this generates a prompt that says translate the text and so on. I encourage you to pause the video and run the code, and also try modifying the prompt to see if you can get a different output.
So we get completion. Okay, let's see. OpenAI.chat. So output is the model. I think this basically send our prompt. So our prompts are messages, right? Okay. Send prompt to the ChatGPT API, and then the output will send back out the output as a response. Okay.
You can then prompt the large language model to get a response. Let's see what the response is. So it's translated the English pirate's message into this very polite, I'm really frustrated that my blender lid flew off and made a mess of my kitchen walls with smoothie, and so on. I could really use your help right now, my friend. That sounds very nice. So if you have different customers writing reviews in different languages, not just English pirate, but French, German, Japanese, and so on, you can imagine having to generate a whole sequence of prompts to generate such translations. Let's look at how we can do this in a more convenient way using Langchain. I'm going to import chat OpenAI. This is Langchain's abstraction for the ChatGPT API endpoint. And so if I then set chat equals chat OpenAI and look at what chat is, it creates this object as follows that uses the ChatGPT model, which is also called GPT 3.5 Turbo. When I'm building applications, one thing I will often do is set the temperature parameter to be equal to 0. So the default temperature is 0.7, but let me actually redo that with temperature equals 0.0. And now the temperature is set to 0 to make its output a little bit less random. And now let me define the template string as follows. Translates the text delimited by triple backticks into style that is style. And then here's the text. And to repeatedly reuse this template, let's import Langchain's chat prompt template. And then let me create a prompt template using that template string that we just wrote above.
Wait, so this section basically we are calling directly to OpenAI API, and this we are using Langchain. Okay, let's see. So the question now is that what's the value
template? You
add
can actually
by
extract
Langchain?
the original prompt, and it realizes that this prompt has two input variables, the style and the text, which were shown here with the curly braces. And here is the original template as well that we had specified. In fact, if we print this out, it realizes it has two input variables, style and text. Now let's specify the style. This is the style that I want the customer message to be translated to. So I'm going to call this customer style. And here's my same customer email as before. And now, if I create custom messages, this would generate the prompt, and we'll pass this to a large language model in a minute to get a response. So if you want to look at the types, the custom message is actually a list. And if you look at the first element of the list, this is more or less that prompt that you would expect this to be creating. Lastly, let's pass this prompt to the LM. So I'm going to call chat, which we had set earlier as a reference to the OpenAI ChatGPT endpoint. And if we print out the customer responses content, then it gives you back this text translated from English
what's
pirate.
the difference between, let me see, okay, so we are putting our prompt in a prompt template this time, okay. So previously what I'm doing is that I am putting my into messages. So, wait, what? Chat, okay. I'm using a prompt template. Okay. Chat. OpenAI. the only difference currently now for now is that, instead of like it's the message part, right?
To polite American English. And of course, you can imagine other use cases where the customer emails are in other languages, and this tool can be used to translate the messages for an English speaking to understand and reply to. I encourage you to pause the video and run the code, and also try modifying the prompt to see if you can get a different output. Now, let's hope our customer service agent reply to the customer in their original language. So let's say English-speaking customer service agent writes this. He says, "Hey there, customer, warranty does not cover cleaning expenses for kitchen because it's your fault that you misused your blender by forgetting to put on the lid. Tough luck, see ya." Not a very polite message, but let's say this is what a customer service agent wants. We are going to specify that the service message is going to be translated to this pirate style. So we want it to be in a polite tone that speaks in English pirate. And because we previously created that prompt template, the cool thing is we can now reuse that prompt template and specify that the output style we want is this service style pirate, and the text is this service reply. And if we do that, that's the prompt. And if we prompt ChatGPT, this is the response it gives us back. Ahoy there, matey. I must kindly inform you that the warranty be not covering expenses or cleaning your galley, and so on. Aye, tough luck. Farewell, me hearty. So you might be wondering, why are we using prompt templates instead of just an F string? The answer is that as you build sophisticated applications, prompts can be quite long and detailed.
Okay, this is something that I would like to know. Why use prompt templates instead of F strings? Okay, good.
And so prompt templates are a useful abstraction to help you reuse good prompts when you can.
Okay, so prompt templates lets us reuse good prompts. Okay.
This is an example of a relatively long prompt to grade a student's submission for an online learning application. And a prompt like this can be quite long, in which you can ask the LM to first solve the problem, and then have the output in a certain format and output in a certain format. And wrapping this in a Langchain prompt makes it easier to reuse a prompt like this. Also, you see later that Langchain provides prompts for some common operations, such as summarization or question answering or connecting to SQL databases or connecting to different APIs. And so by using some of Langchain's built-in prompts, you can quickly get an application working without needing to engineer your own prompts. One other aspect of Langchain's prompt libraries is that it also supports output parsing, which we'll get to in a minute. But when you're building a complex application,
Langchain library functions parsed. Oh, this is interesting. Users' thoughts. Action and observation for chain of thought reasoning. Okay.
Using an LLM, you often instruct the LLM to generate its output in a certain format, such as using specific keywords. This example on the left illustrates using an LLM to carry out something called chain of thought reasoning using a framework called the React framework. But don't worry about the technical details, but the keys of that is that the thought is what the LLM is thinking, because by giving an LLM space to think, it can often get to more accurate conclusions. Then action as a keyword to carry the specific action, and then observation to show what it learned from that action, and so on. And if you have a prompt that instructs the LLM to use these specific keywords, thought, action, and observation, then this prompt can be coupled with a parser to extract out the text that has been tagged with these specific keywords. And so that together gives a very nice abstraction to specify the input to an LLM, and then also have a parser correctly interpret the output that the LLM gives. And so with that, let's return to see an example of an output parser using Langchain. In this example, let's take a look at how you can have an LLM output JSON and use Langchain to parse that output. And the running example that I'll use will be to extract information from a product review and format that output in a JSON format. So here's an example of how you would like the output to be formatted. Technically, this is a Python dictionary, where whether or not the product is a gift maps to false, the number of days it took to deliver was 5, and the price value was pretty affordable. So this is one example of a desired output. Here is an example of customer review, as well as a template to try to get to that JSON output. So here's a customer review. It says, the sleep blower is pretty amazing. It has 4 settings: candle blower, gentle breeze, windy city, and tornado. it arrived in 2 days, just in time for my wife's anniversary present. I think my wife liked it so much she was speechless. So far, I've been the only one using it, and so on. And here's a review template. For the following text, extract the following information. Specify, was this a GIF? So in this case, it would be yes, because it's a GIF. And also delivery days. How long did it take to deliver? It looks like in this case, it arrived in 2 days. And what's the price value? You know, slightly more expensive than leaf blowers, and so on. So the review template asks the LLM to take as input a customer review and extract these 3 fields, and then format the output as JSON with the following keys. All right. So here's how you can wrap this in Langchain. Let's import the chat prompt template. We'd actually imported this already earlier, so technically this line's redundant, but I'll just import it again and then have the prompt template created from the review template up on top. And so here's the prompt template. And now, similar to our earlier usage of a prompt template, let's create the messages to pass to the OpenAI endpoint, create the OpenAI endpoint, call that endpoint, and then let's print out the response. I encourage you to pause the video and run the code. And there it is. It says GIF is true, delivery days is 2, and the price value also looks.
Okay, why is it? Wait, let me see the prompt. Okay, output parser. Okay, customer review. Text equals to customer review. Okay, this leaf. Okay, what the heck is going on here? Let's see. So from chat template, print. So this is my prompt, which is this. Oh, this is my prompt. Okay. And then I just pass my prompts. So basically, I wrapped my prompt into a prompt template, Langchain prompt chat prompt template, and then I pass it to the model. I send it to the model. Okay, let's see. So format messages, interesting. That's interesting. This is my template, then this is my prompt. Oh, okay, I know what it means. This is my input, right? Okay. So I'll get a chat, and then, okay. Format the output as JSON with following keys. Okay, cool.
Pretty accurate. But note that if we check the type of the response, this is actually a string. So it looks like JSON and looks like it has key value pairs, but it's actually not a dictionary. This is just one long string. So what I really like to do is go to the response content and get the value from the GIF key, which should be true. But I run this should generate an error because, well, this is actually a string. This is not a Python dictionary.
So this is basically where parser comes in, I guess.
So let's see how we would use Langchain's parser in order to do this. I'm going to import response schema and structured output parser from Langchain. And I'm going to tell it what I want it to parse by specifying these response schemas. So the gift schema is named gift, and here's the description. Was the item purchased a gift for someone else? Answer true if yes, false if not so unknown, and so on. So have a gift schema, delivery day schema, price value schema, and then let's put all 3 of them into a list as follows. Now that I've specified the schema for these, Langchain can actually give you the prompt itself by having the output parser tell you what instructions it wants you to send to the LM. So if I were to print format instructions, here's a pretty precise set of instructions for the LM that will cause it to generate an output that the output parser can process. So here's a new review template, and the review template includes the format instructions that Langchain generated. And so we can create a prompt from the review template.
Okay, let me see what happens here. Okay, so content, type content, okay. Pass the LM output string into a Python dictionary. What? Response schema, structured output parser. Okay.
output to, and then create the messages that will pass to the OpenAI endpoint. If you want, you can take a look at the actual prompt, which gives the instructions to extract the fields gift, delivery days, price value. Here's the text, and then here are the formatting instructions. Finally, if we call the OpenAI endpoint, let's take a look at what response we got. It is now this. And now if we use the output parser that we created earlier, you can then parse this into an output dictionary, which if I print looks like this. And notice that this is of type dictionary, not a string, which is why I can now extract the value associated with the key gift and get true, or the value associated with delivery days and get 2, or you can also extract the value associated with price value. So this is a nifty way to take your LLM output and parse it into a Python dictionary to make the output easier to use in downstream processing. I encourage you to pause the video and run the code. And so that's it for models, prompt, and parsers. With these tools, hopefully you'll be able to reuse your own prompt templates easily, share prompt templates with others that you collaborate.
Okay, that's interesting. Very interesting.
With, even use Langchain's built-in prompt templates, which, as you just saw, can often be coupled with an output parser, so that the input prompt to output in a specific format, and then the parser parses that output to store the data in a Python dictionary or some other data structure that makes it easy for downstream processing. I hope you find this useful in many of your applications. And with that, let's go on to the next video where we'll see how Langchain can help you build better chatbots, or have an LLM have more effective chats by better managing what it remembers from the.
That's interesting. Memory.
When you interact with these models, naturally they don't remember what you say before or any of the previous conversation, which is an issue when you're building some applications like chatbot. And
Yeah, let me take a break, man. Let's see what's. Let's
you want to
continue.
have a conversation with them. And so in this section, we'll cover memory, which is basically how do you remember previous parts of the conversation and feed that into the language model so that they can have this conversational flow as you're interacting with them.
Yep. So Langchain offers multiple sophisticated options for managing these memories. Let's jump in and take a look. So let me start off by importing my OpenAI API key, and then let me import a few tools that I'll need. let's use as the motivating example for memory, using Langchain to manage a chat or chatbot conversation. So to do that, I'm going to set the LLM as the chat interface of OpenAI with temperature equals 0. And I'm going to use the memory as a conversation buffer memory. And you'll see later what this means. And I'm going to build a conversation chain. Again, later in this short course, Harrison will dive much more deeply into what exactly is a chain in Langchain. So don't worry too much about the details of the syntax for now. But this builds an LLM. And
so this is basically the model. And then there's a memory. And then there's actually a function called conversation chain where you can combine your LM, the memory, and okay.
If I start the conversation.predict, give the input, hi, my name is Andrew. Let's see what it says. Hello, Andrew, nice to meet you, right? And so on. And then let's say I ask it, what is 1 plus 1? 1 plus 1 is 2, and then ask it again, what's my name? Your name is Andrew, as you mentioned earlier. It's a little bit of a trace of sarcasm there. Not sure. And so if you want, you can change this verbose variable to true to see what Langchain is actually doing. When you run predict hi, my name is Andrew, this is the prompt that Langchain is generating. It says, the following is a friendly conversation between a human and an AI is talkative, and so on. So this is a prompt that Langchain has generated to have the system have a hopeful and friendly conversation, and it has to save the conversation, and here's the response. And when you execute this on the second and third parts of the conversations, it keeps the prompt as follows. And notice that by the time I'm uttering what is my name, this is the third turn, that's my third input, it has stored the current conversation as follows. Hi, my name is Andrew, what is 1 plus 1, and so on. And so this memory or this history of the conversation gets longer and longer. In fact, up on top, I had used the memory variable to store the memory. So if I were to print memory.buffer, it has stored the conversation so far. You can also print this out, memory.load memory variables. The curly braces here is actually an empty dictionary. There's some more advanced features that you can use with a more sophisticated input, but we won't talk about them in this short course. So don't worry about why there's empty curly braces here. But this is what Langchain has remembered in the memory of the conversation so far. It's just everything that the AI or that the human has said. I encourage you to pause the video and run the code. So the way that Langchain is storing the conversation is with this conversation buffer memory. If I were to use the conversation buffer memory to specify a couple of inputs and outputs, this is how you add new things to the memory if you wish to do so explicitly. Memory.saveContext says, hi, what's up? I know this is not the most exciting conversation, but I wanted to have a short example.
Okay, that's interesting. Memory in our chain. Okay.
And with that, this is what the status of the memory is. And once again, let me actually show the memory variables. Now, if you want to add additional data to the memory, you can keep on saving additional context. So conversation goes on, not much, just hanging, cool. And if you print out the memory, there's now more stuff in it. So when you use a large language model for a chat conversation, the large language model itself is actually stateless. The language model itself does not remember the conversation you've had so far, and each transaction, each call to the API endpoint is independent. And chatbots appear to have memory only because there's usually wrapper code that provides the full conversation that's been had so far.
Okay, this is very interesting. So, okay. I mean, this is nothing new. It's just that the way they put it is interesting. Stateless. Each transactions is independent. Chatbots appear to have memory by providing the full conversation as context. Okay, looks good.
Are as context to the LLM. And so the memory can store explicitly the turns or the utterances so far. Hi, my name is Andrew. Hello, it's nice to meet you, and so on. And this memory storage is used as input or additional context to the LLM so that it can generate an output as if it's just having the next conversational turn, knowing what's been said before. And As a conversation becomes long, the amount of memory needed becomes really, really long, and thus the cost of sending a lot of tokens to the LLM, which usually charges based on the number of tokens it needs to process, will also become more expensive. So Langchain provides several convenient kinds of memory to store and accumulate the conversation. So far, we've been looking at the conversation buffer memory. Let's look at a different type of memory. I'm going to import the conversation buffer window memory that only keeps a window of memory. If I set memory to conversational buffer window memory with k equals 1, the variable k equals 1 specifies that I want it to remember just one conversational exchange. That is one utterance from me and one utterance from the chatbot. So now if I were to have it say context, hi, what's up, not much, just hanging. If I were to look at memory.load variables, it only remembers the most recent utterance. Notice it's dropped. Hi, what's up? It's just saying, human says not much, just hanging, and the AI says cool. So that's because k was equal to 1. So this is a nice feature because it lets you keep track of just the most recent few conversational terms. In practice, you probably won't use this with k equals 1. You use this with k set to a larger number, but still this prevents the memory from growing without limit as the conversation goes longer. And so if I were to rerun the conversation that we had just now, we'll say, hi, my name is Andrew. What is 1 plus 1? And now I ask it, what is my name? Because k equals 1, it only remembers the last exchange, which is what is 1 plus 1? The answer is 1 plus 1 equals 2, and it's forgotten this early exchange, which is now says, sorry, don't have access to that information. One thing I hope you would do is pause the video, change this to true in the code on the left, and rerun this conversation with verbose equals true, and then you will see the prompts actually used to generate this, and hopefully you see that the memory, when you're calling the LM on what is my name, that the memory has dropped this exchange where it learned what is my name, which is why it now says it doesn't know what is my name. With the conversational token buffer memory, the memory will limit the number of tokens saved. And because a lot of LLM pricing is based on tokens, this maps more directly to the cost of the LLM calls. So if I were to say the max token limit is equal to 50, and actually let me inject a few comments. So let's say the conversation is, AI is what? Amazing. Background question is what? Beautiful. Chatbots are what? Charming. I use ABC as the first letter of all of these conversational terms. We can keep track of what was sent when. If I run this with a high token limit, it has almost the whole conversation. If I increase the token limit to 100, it now has the whole conversation, starting with AI is what. If I decrease it, then it chops off the earlier parts of this conversation to retain the number of tokens corresponding to the most recent exchanges, but subject to not exceeding the token limit. And in case you're wondering why we needed to specify an LLM, is because different LLMs use different ways of counting tokens. So this tells it to use the way of counting tokens that the chat OpenAI LLM uses. I encourage you to pause the video and run the code, and also try modifying the prompt to see if you can get a different output. Finally, there's one last type of memory I want to illustrate here, which is the conversation summary buffer memory. And the idea is, instead of limiting the memory to a fixed number of tokens based on the most recent utterances or a fixed number of conversational exchanges, let's use an LLM to write a summary of the conversation so far and let that be the memory. So here's an example where I'm going to create a long string with someone's schedule. There's meeting AM with your product team, you need your PowerPoint presentation, and so on and so on. So there's a long string saying what's your schedule. Maybe ending with a noon lunch at the Italian restaurant with a customer, bring your laptop, show the latest LLM demo. And so let me use a conversation summary buffer memory with a max token limit of 400 in this case, pretty high token limit. And I'm going to insert in a few conversational terms in which we start with hello, what's up, not much, just hanging, cool, and then what is on the schedule today? And the response is that long schedule. So this memory now has quite a lot of text in it. In fact, let's take a look at the memory variables. It contains that entire piece of text because 400 tokens was sufficient to store all this text. But now, if I were to reduce the max token limit, say to 100 tokens, remember this stores the entire conversational history. If I reduce the number of tokens to 100, then the conversation summary buffer memory has actually used an LLM, the OpenAI endpoint in this case, because that's what we set the LLM to actually generate a summary of the conversation so far. So the summary is human AI engaged in small talk before discussing the schedule, AI informs human in morning meeting, blah, 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 lunch meeting with customer interested in latest AI developments. And so if we were to have a conversation using this LLM, let me create a conversation chain, same as before. And let's say that we were to ask, input what would be a good demo to show. I said verbose equals true, so here's the prompt. The LLM thinks the current conversation has had this discussion so far, because that's the summary of the conversation. And just one note, if you're familiar with the OpenAI chat API endpoint, there is a specific system message. In this example, this is not using the official OpenAI system message. It's just including it as part of the prompt here, but it nonetheless works pretty well. And given this prompt, the outputs based on custom features in AI development, so it's just showcasing our latest NLP capabilities. Okay, that's cool. Well, it's making some suggestions to the cool demos and makes you think, if I was meeting a customer, I would say, boy, if only there were open source framework available to help me build cool NLP applications using LLMs. Good things on Langchain. And the interesting thing is, if you now look at what has happened to the memory, so notice that here it has incorporated the most recent AI system output, whereas my utterance asking it what would be a good demo to show has been incorporated into the system message, the overall summary of the conversation so far. With the conversation summary buffer memory, what it tries to do is keep the explicit storage of the messages up to the number of tokens we have specified as a limit. So, this part, the explicit storage, we're trying to cap at 100 tokens because that's what we've asked for. And then anything beyond that, it will use the LM to generate a summary, which is what is seen up here. And even though I've illustrated these different memories using a chat as a running example, these memories are useful for other applications too, where you might keep on getting new snippets of text or keep on getting new information, such as if your system repeatedly goes online to search for facts, but you want to keep the total memory used to store this growing list of facts as capped and not growing arbitrarily long. I encourage you to pause the video and run the code. In this video, you saw a few types of memory, including buffer memories that limits based on number of conversation exchanges or tokens, or a memory that can summarize tokens above a certain.
This is interesting, very interesting. So conversation buffer memory basically means so buffer window means last k interactions token length creates a summary of conversation. Okay, looks good.
Limits. Langchain actually supports additional memory types as well. One of the most powerful is vector data memory. If you're familiar with word embeddings and text embeddings, the vector database actually stores such embeddings. If you don't know what that means, don't worry about it. Harrison will explain it later. And it can then retrieve the most relevant blocks of text using this type of vector database for its memory. And Langchain also supports entity memories, which is applicable when you wanted to remember details about specific people, specific other entities, such as if you talk about a specific friend, you can have Langchain remember facts about that friend, which would be an entity in an explicit way. When you're implementing applications using Langchain, you can also use multiple types of memories, such as using one of the types of conversation memory that you saw in this video, plus additionally, entity memory to recall individuals. So this way it can remember maybe a summary of the conversation, plus an explicit way of storing important facts about important people in the conversation. And of course, in addition to using these memory types, it's also not uncommon for developers to store the entire conversation in a conventional database, some sort of key value store or SQL database, so you could refer back to the whole conversation for auditing or for improving the system further. And so that's memory types. I hope you find this useful building your own applications. And now let's go on.
All right, this looks cool. Chains.
In this lesson, Harrison will teach the most important key building block of Langchain, namely the chain. The chain usually combines an LLM, large language model, together with a prompt. And with this building block, you can also put a bunch of these building blocks together to carry out a sequence of operations on your text or on your other data.
I'm excited to dive into it. All right, to start, we're going to load the environment variables as we have before. And then we're also going to load some data that we're going to use. So part of the power of these chains is that you can run them over many inputs at a time. Here we're going to load a pandas data frame. A pandas data frame is just a data structure that contains a bunch of different elements of data. If you're not familiar with pandas, don't worry about it. The main point here is that we're loading some data that we can then use later on. And so if we look inside of this pandas data frame, we can see that there is a product column and then a review column. And each of these rows is a different data point that we can start passing through our chains. So the first chain we're going to cover is the LLM chain. And this is a simple but really powerful chain that underpins a lot of the chains that we'll go over in the future. And so we're going to import three different things. We're going to import the OpenAI model, so the LLM. We're going to import the chat prompt template, and so this is the prompt. And then we're going to import the LLM chain. And so first, what we're going to do is we're going to initialize the language model that we want to use. So we're going to initialize the chat OpenAI with a high temperature, so that we can get some fun descriptions. Now we're going to initialize a prompt, and this prompt is going to take in a variable called product. It's going to ask the LLM to generate what the best name is to describe a company that makes that product. And then finally, we're going to combine these two things into a chain. And so this is what we call an LLM chain, and it's quite simple. It's just a combination of the LLM and the prompt. But now this chain will let us run through the prompt and into the LLM in a sequential manner. And so if we have a product called queen size sheet set, we can run this through the chain by using chain.run. And what this will do is it will format the prompt under the hood.
Okay, product.
And then it will pass the whole prompt into the LLM. And so we can see that we get back the name of this hypothetical company called Royal Beddings. And so here would be a good time to pause, and you can input any product descriptions that you would want, and you can see what the chain will output as a result. So the LLM chain is the most basic type of chain, and that's going to be used a lot in the future. And so we can see how this will be used in the next type of chain, which will be sequential chain.
Chain is basically model plus prompt. Okay.
And so sequential chains run a sequence of chains one after another. So to start, you're going to import the simple sequential chain. And this works well when we have subchains that expect only one input and return only one output. And so here we're going to first create one chain, which uses an LLM and a prompt. And this prompt is going to take in the product and will return the best name to describe that company. So that will be the first chain. Then we're going to create a second chain. And the second chain will take in the company name and then output a 20-word description of that company. And so you can imagine how these chains might want to be run one after another, where the output of the first chain, the company name, is then passed into the second chain. We can easily do this by creating a simple sequential chain where we have the two chains described there. And we'll call this overall simple chain. Now, what you can do is run this chain over any product description. And so if we use it with the product above, the queen size sheet set, we can run it over and we can see that it first outputs royal bedding, and then it passes it into the second chain and it comes up with this description of what that company could be about. The simple sequential chain works well when there's only a single input and a single output. But what about when there are multiple inputs or multiple outputs? And so we can do this by using just the regular sequential chain. So let's import that, and then you're going to create a bunch of chains that we're going to use one after another. We're going to be using the data from above, which has a review. And so the first chain, we're going to take the review and translate it into English. With the second chain, we're going to create a summary of that review in one sentence. And this will use the previously generated English review. The third chain is going to detect what the language of the review was in the first place. And so if you notice, this is using the review variable that is coming from the original review. And finally, the fourth chain will take in multiple inputs. So this will take in the summary variable, which we calculated with the second chain, and the language variable, which we calculated with the third chain. And it's going to ask for a follow-up response to the summary in the specified language. One important thing to note about all these subchains is that the input keys and output keys need to be pretty precise. So here we're taking in review. This is a variable that will be passed in at the start. We can see that we explicitly set the output key to English review. This is then used in the next prompt down below, where we take in English review with that same variable name. And we set the output key of that chain to summary, which we can see is used in the final chain. The third prompt takes in review, the original variable, and outputs language, which is again used in the final prompt. It's really important to get these variable names lined up exactly right, because there's so many different inputs and outputs going on. And if you get any key errors, you should definitely check that they are lined up so. The simple sequential chain takes in multiple chains where each one has a single input and a single output. To see a visual representation of this, we can look at the slide where it has one chain feeding into the other chain, one after another. Here we can see a visual description of the sequential chain. Comparing it to the above chain, you can notice that any step in the chain can take in multiple input variables. This is useful when you have more complicated downstream chains that need to be a composition of multiple previous chains. Now that we have all these chains, we can easily combine them in the sequential chain. So you'll notice here that we'll pass in the 4 chains we created into the chains variable. We'll create the inputs variable with the one human input, which is the review. And then we want to return all the intermediate outputs, so the English review, the summary, and then the follow-up message. Now we can run this over some of the data. So let's choose a review and pass it in through the overall chain. We can see here that the original review looks like it was in French. We can see the English review as a translation. We can see a summary of that review, and then we can see a follow-up message in the original language of French. You should pause the video here and try putting in different inputs. So far, we've covered the LLM chain and then a sequential chain. But what if you want to do something more complicated? A pretty common but basic operation is to route an input to a chain depending on what exactly that input is. A good way to imagine this is if you have multiple subchains, each of which is specialized for a particular type of input, you could have a router chain, which first decides which subchain to pass it to and then passes it to that chain. For a concrete example, let's look at where we are routing between different types of chains depending on the subject that seems to come in. So we have here different prompts. One prompt is good for answering physics questions. The second prompt is good for answering math questions, the third for history, and then a fourth for computer science. Let's define all these prompt templates. After we have these prompt templates, we can then provide more information about them. We can give each one a name and then a description. This description for the physics one is good for answering questions about physics. This information is going to be passed to the router chain. So the router chain can decide when to use this subchain. Let's now import the other types of chains that we need. Here we need a multi-prompt chain. This is a specific type of chain that is used when routing between multiple different prompt templates. As you can see, all the options we have are prompt templates themselves. But this is just one type of thing that you can route between. You can route between any type of chain. The other classes that we'll implement here are an LLM router chain. This uses a language model itself to route between the different subchains. This is where the description and the name provided above will be used. We'll also import a router output parser. This parses the LLM output into a dictionary that can be used downstream to determine which chain to use and what the input to that chain should be. Now we can get around to using it. First, let's import and define the language model that we will use. We now create the destination chains. These are the chains that will be called by the router chain. As you can see, each destination chain itself is a language model chain, an LLM chain. In addition to the destination chains, we also need a default chain. This is a chain that's called when the router can't decide which of the subchains to use. In the example above, this might be called when the input question has nothing to do with physics, math, history, or computer science. Now we define the template that is used by the LLM to route between the different chains. This has instructions of the task to be done, as well as the specific formatting that the output should be in. Let's put a few of these pieces together to build the router chain. First, we create the full router template by formatting it with the destinations that we defined above. This template is flexible to a bunch of different types of destinations. One thing you can do here is pause and add different types of destinations. So up here, rather than just physics, math, history, and computer science, you could add a different subject, like English or Latin. Next, we create the prompt template from this template, and then we create the router chain by passing in the LLM and the overall router prompt. Note that here we have the router output parser. This is important as it will help this chain decide which subchains to route between. And finally, putting it all together, we can create the overall chain. This has a router chain, which is defined here. It has destination chains, which we pass in here, and then we also pass in the default chain. We can now use this chain. So let's ask it some questions. If we ask it a question about physics, we should hopefully see that it is routed to the physics chain with the input, what is black body radiation, and then that is passed into the chain down below, and you can see that the response is very detailed with lots of physics details. You should pause the video here and try putting in different inputs. You can try with all the other types of special chains that we have defined above. So for example, if we ask it a math question, we should see that it's routed to the math chain and then passed into that. We can also see what happens when we pass in a question that is not related to any of the subchains. So here, we ask it a question about biology, and we can see the chain that it chooses is none. This means that it will be passed to the default chain, which itself is just a generic call to the language model. The language model luckily knows a lot about biology, so it can help us out here. Now that we've covered these basic building blocks types of chains, we can start to put them together to create really interesting.
Okay, interesting.
interesting applications. For example, in the next section, we're going to cover how to create a chain.
One of the most common
Yeah, should I call it a day? I'm a bit tired too. Have I been streaming for 1 hour? No, right? What time do I start actually? 4:21. Oh my. Yeah, definitely lots of resources here, I would say. From engineering, unstructured, comet, quantization. Interesting. Yeah, so many tools and whatnot here. That's interesting. Large multimodal prompting with Gemini. All these are very interesting, to be honest. Very interesting, very interesting. Multimodal RAG. Wow. Okay. So many courses here too. That's the thing. Multimodal RAG. What the heck is multimodal RAG? Multimodal RAG system of large visual language models. Damn. I'm having trouble actually keeping up with the advancement of LLMs. Okay. Right, I think I'll call it a day.